Welcome you students. The next topic is types of load. Okay. So here we have three kinds of load namely. So first one is point load or concentrated load. Concentrated load. Other name is a concentrated load for the point load. And the second one is uniformly distributed load. Distributed load. So this load, in short, we call it as UDL, uniformly distributed load, or else other name is rectangular load. Rectangular load. The third one is uniformly varying load. Uniformly varying load. So in short, UVL we call it as, or else other name is a triangular load. Triangular load. Okay, these are the three loads we gonna see. So first one, point load. So point load is nothing but, for example, I have a beam AB. Okay, so both the end which is supported by the one of the end is a hinged support, and the another end which is supported by the roller support, something like this. I'm going to take the consideration. Okay, both the ends. So at the mid of it there is a load which I going to denote it as P. That means point load, in the sense what it say is a load which is acting at a point on the beam. Okay, a load which is acting at a point on the beam, that kind of load we can call it as point load or concentrated load. Okay, a load which is acting at a point on a beam, which is known as point load or concentrated load. The second one is uniformly distributed load. Okay, UDL. So here this uniformly distributed load, in the sense when the intensity of the load is constant over a considerable length. That means if I consider a beam AB and which is supported just like a similar fashion which I have taken in the previous, one end is roller and another one is a hinge support, something like this. The load which is just been concentrated to the entire length. Okay, if I take this length as capital L, the entire length the load is being concentrated in the similar fashion, something like this. Okay, so the load intensity can be taken as W. Okay, I'm going to consider it as W, and this intensity of load can be considered in the unit Newton per meter. Okay, this load is acting where? In the considerable length. Am I right? So we are taking load, that means Newton per meter. Okay, acting in the per unit meter, right? Fine. So in the other manner also we can represent this uniform distributed load. Based upon the name, it can also be noted something like this. That means we said it's a rectangular load, right? So in some places they used to represent the distribution of load something like this. It's a same. Okay, it's a uniform distributed or rectangular load. Okay, so here as well the load which can be noted as W, and here the unit Newton meter. So when you come to the point load, the unit actually is Newton. That's all. Okay, Newton, just a Newton. Okay, can be unit unit. Okay, SI unit is Newton, but here Newton meter. Okay, fine. So whenever you are going to the problem, okay, when you are solving the problems, actually when you are coming across this kind of uniform distributed load, we need to convert it to the point load. Okay, we need to simplify it, right? Then only we can proceed it well, right? So for that, what we do is we used to convert this. That means if I consider this as a uniformly distributed load here, we need to convert it to the point load. So for that, I can take this as A point, this is a B. Okay, beam with the A and B, this end and this end. In a similar way I'm going to represent it. Okay, if you want to replace with a point load P, then it is being said the point load intensity should be taken for this load as W, its load value, into the length, how long it is conveyed, how long it is distributed. Okay, that length we must multiply with it. Load into what? The displaced length. Okay, then we can convert the the uniformly distributed load into the point load. Okay, W into L. So here the load is Newton meter, right? And the length of the measurement will be in meter. So meter get cancelled. The unit will be what? Newton. That means I am talking about SI unit. SI unit. So when you talk about the SI unit, we get what? The Newton, right? I hope you understood this. Okay, so point load W into L, and we shall know where it actually located on the beam between A and B. Okay, so acting point, actually the acting point for the uniformly distributed load is 1 by 2 of its length. That means 1 by 2 of its length. Okay, 1 by 2 of its length will be from the ends. If you take from the B to P end, it will be 1 by 2 of its length. If you take it from A to B, then it will be 1 by 2 of its length. Okay, it says it is just acting at the mid of the beam. Okay, that is the point, acting at the mid of the point when you come to the uniformly distributed load. So then move to the third one, uniformly varying load, UVL. Okay, uniformly varying load. Here actually the load intensity will be varying from the one end to other end with a linear manner. Okay, so that means I can show there is a beam AB with a support, hinge support and roller support, just like a previous one. Okay, so here the load is just varying, the intensity of the load is just varying linearly over a considerable length. If I take the beam which is with length L, the entire length which is conveying or distributing linear manner, which is varying from one end to another end. One end the load will be a minimum and the other end will be a maximum. Okay, right? Fine. It can also located on the beam something like this as well. If it is A and B, maximum to minimum, something like that also possible on the questions. Okay, fine, right? So here I said always when you're coming to the uniformly distributed load, we need to convert it into point load. Am I right? The similar manner we need to convert this uniformly varying load into point load. The point is, if I consider A and B ends, okay, it is with a length L, it is with the length L. Okay, here if you want to place the point load, if I want to convert this load into point load, in the similar manner the uniformly distributed load, here as well the load is W. Okay, and the unit SI unit is Newton per meter. Okay, fine. Here if I want to convert it into point load, okay, point load, it is just a formula 1 by 2 into load into its length, distributed load, 1 by 2 into half of the load into its length. It's just like a triangular formula. Okay, right angle triangle formula, half into that load into x distributed length. Okay, fine. So here the load is 1 by 2, the point load can be 1 by 2 load into the length. Okay, fine. So its unit is Newton. Okay, just like previous one, uniform distributed load, when you are converting into point load, its load is Newton. Similar manner here as well, you will get Newton. Okay, then acting point, where it actually located with respect to both the ends, where it actually located with respect to A end and B end, where it is located. So I can say it is being determined from the minimum end, it will be the point load will be located 2 by 3 of its length. Okay, from the minimum, when you are locating from the minimum, here is the minimum point, am I right? From the minimum, if you take, the length will be from the A, which will 2 by 3 of its length. If you are taking, it's a 2 by 3 of its length. If you are taking from the maximum to the point load, okay, when you are taking maximum to the point load, the acting point will be varying. Okay, that will be 1 by 3 into its length. This formula is for the acting point formula, which if you consider from the maximum, if you take from the maximum point, here is the maximum load, right? Maximum to that point, in the sense from the B end we have to place 1 by 3 into N. Okay, so please just put it in your mind, when you are point load, in the sense a load which is acting at a point, at a single point, which is called as point load. Uniform distributed load, in the sense the load is concentrated throughout the length of the beam in the similar manner. The intensity will be distributed just in uniform manner from one end to another end. Uniform varying load, in the sense the load will be distributed linearly varying manner. Okay, one end it will be minimum and another end will be maximum, or one end will be maximum and the other end will be minimum, something like this the arrangement will be. And when you are coming the uniform distributed load and uniform varying load, just we need to convert it into point load. Okay, so when you are converting into point load, here in the uniform distributed load, the point load should be multiplied by in order to convert it into point load, we have to multiply the load into its distance. Here comes, in order to identify the load intensity, we have to multiply, that means load, half the load and the distance. Okay, half the load into its distance, right? Fine. So here since it is uniformly distributed, the point load will act at the mid of the beam. Okay, off into length, it's acting in the mid of the beam. But here the acting point is, when you are just taking from the minimum point, 2 by 3 of its length. When you are taking from the maximum point, it is 1 by 3 of its length. Okay, 1 by 3 of its length. Okay, I hope you understood. And the last one is equilibrium condition. for the rigid body. It is important one. Okay, so rigid bodies here for 2D, the sum of horizontal force is equal to 0, sum of vertical force is equal to 0, and the resultant force is equal to 0. And as well, the last one is a moment about any point, sum of moment about any point is equal to 0. This is the equilibrium condition for the rigid body. Okay, rigid body. So when you are just placing the supports, or when you are supporting the beam with the help of kind of support which I taught you in the previous class, when you are supporting it, definitely in order to support the beam, the condition must be in the equilibrium. So equilibrium in the sense, number of force acting on the body is equal to 0. That is, summation of H is equal to 0, V is equal to 0, resultant force is equal to 0, moment is equal to 0. Okay, I hope you understood. Thank you so much.